Question 9. The weight in kilogram of 50 students in a competition is as follows. So you have for the first row 66, 66, 67, 66, 64, 66, 65, 63, 65, 68, and so on. A part of the question: construct a frequency table for the discrete data. B. Calculate correct to 2 decimal places. D. Figure 1, mean. Figure 2, standard deviation of the data. Solution: you have the same weight data here. Then A, we are to construct a frequency table. Now we use S to denote the weight. Now the data point, they are very close, so here we cannot form class interval, rather we use them the way they are. You simply look for the least weight, that is 62, and the highest weight is 68. Then you list them in this form: 62, 63, 64, 65, 66, 67, 68. In order to know how many times each weight occur, that is frequency, you can use tally. Tally is stroke representation of frequency. To do that, you use your pencil or biro. Now the first weight, I'm going to strike it off and record it with a stroke against 66. The next one, 64, you strike it off and record it against 64, followed by 65, you record it against 65. You have 66, you record it against 66. You have 66 again, you record it against 66. You do that for all the data point. After doing that, you have these tallies. Now a bundle of tally contains 5 strokes. You have 4. You use the fifth one to join or cross the 4 together. So if the tally is written as frequency, one stroke means 1. So bundle of 5, then you have 5. For 64, you have 12. For 65, you have 14. For 66, you have 10. For 67, you have 6. For 68, you have 2. If you add all together, you have 50. Now let's get the mean. The mean for data involving frequency is simply the summation of fs, that is product of frequency and the weight divided by sum of frequency. For that, you need to add the next column, fs, and for fs, this your s, this your f, so you multiply 62 by 1, you have 62. The next one, 63 times 5, you have 315. 64 times 12, you have 7, 6, 8, and so on. Because the sum is needed, if you add everything in the fs column, you have 3253. So you divide it by 50, and that gives the mean weight as 65.06 kilogram to the nearest or to 2 decimal places. Figure 2, you are asked to find the standard deviation. you have this formula or this. The second one is the expanded form of the first formula. Both will give the same result, but the second one is easier to work with, because if you are to work with this, you have to look for s minus the mean, you square it, multiply by f before you add. So I'm going to add about 3 columns to the table after fs column. So I'm going by the second one. The second one is summation fs squared, that is under square root, over summation f minus bracket open summation fs over summation f bracket close or square, the same as the mean that you've obtained earlier. So by the second formula, I need to compute s squared. So you come and square each value here. If you square each value here, you have this result. Then for f squared, you use fs squared, the frequency 1, to multiply the first s squared here, you get this result. The next frequency is 5 times the next number, you get the second one. Now let's jump to 10 times 4, 3, 5, 6, you get this result. Summation fs squared means you add everything in this column and you have 211,733. You replace it with that value, you divide by 50 minus the mean 65.06 all square under square root. So you have square root. If you divide this value, you have 4234.66 minus, if you square the mean, you have 4232.8036. If you subtract, you have square root of 1.8564. To 2 decimal places, you have 1.36 as the standard deviation of the discrete data.